Hello, good afternoon to all of you. I hope all of you are doing well. So in today's class, we are going to discuss about data types in C++. The data types in C++ are basically categorized into three different categories. The names are primary category, derived category, and user-defined category. In primary data type, what we have is we have integer, character, floating point, and void. In case of derived category, we have arrays, functions, pointers, and reference. In case of user-defined category, we have class, structure, union, enumeration, and type definition. So these are the three different categories in which the data types in C++ are categorized into. Now here what we have is we have the data types being specified and the byte requirement of the individual data types that are there, right? Okay. So for character you require 1 byte. Both for signed and unsigned character you require 1 byte. For integer you require 4 bytes. For signed and unsigned integer you require 4 bytes. For short integer you require 2 bytes. For signed and unsigned short integer you require 2 bytes. Long integer requires 8 bytes. For signed and unsigned long integer you require 8 bytes. Long integer requires 8 bytes. Unsigned long integer requires 8 bytes. Float requires 4 bytes. Double requires 8 bytes, and long double requires 12 bytes. Okay. Right. So these are the byte requirement for the individual data type, right? So now because for the other it depends on the type of combinations that you create, right? For structure union depends on the type of combination you can create. So associated with each and every data type, the range is also specified here. Now let us move on to the derived data type. The first derived data type, that is array. So an array is a composite variable. Okay, right? So an array is a composite variable that is used to hold values of same type in continuous memory location. Again, I'll repeat it. Array is a composite variable that is used to hold values of same type in continuous memory location. So that is the definition of an array. Okay, so it's a composite variable because it's composed of multiple values, but what kind of values? Same values. So you can have array of type integer, you can have array of type floating point number, you can have array of type character, but you cannot have array of type mixed mode where you can hold all the possible types of values. So it's a collection of same type of values stored in continuous memory location, one after the other. Okay. So now how to declare an array? An array is declared in this particular manner. So you have the type being specified, you have the array name, and you have the array size being placed inside a pair of square brackets. So here you have the type of the array. So you have integer type, okay, array name is a and the size is 10. So that is the way how array is declared. So here this bracket is just used as a delimiter to separate the array name and the array size. So this is the declaration syntax for an array. So you have to specify the type first, followed by the array name, and followed by the size. Now, the array size must be an integer. This is a very important requirement. The array size must be an integer constant greater than 0. Okay, right? Okay, it should be integer constant and should be greater than that of 0. So this is very much important. So again, I'll redefine array. Array is it's a composite data type that is capable, a composite variable that is capable of holding value of same type in continuous memory location. It is declared in this particular manner where you specify the type first, followed by the array name, and followed by the array size. Okay, and the array size always has to be an integer constant that is greater than 0. Now, how to declare an array? So here what we have is we have an array by the name balance whose size is 5 and it's capable of holding double. So value of type double. So the values are initialized here. So in the second case, depending upon the number of values that are there in the initialization, the size of balance will be determined. Okay, right? And here if you want to specify initialize a specific location in the balance, so what you can do is you can do it in this particular manner. So the fourth position in the array is initialized with 50. So here one thing what you need to remember is the so in case of array declaration, just see it is not specified. It may or may not be specified here, but just remember array name itself is the pointer to the starting array definition in memory. That means it will point to the first value of the array in computer's memory. So array name itself is a pointer to the first value of the array in the computer's memory. So that is the way how what that is the significance of the array name. Okay, so array name marks the beginning of array definition in memory, and whenever you are referring to any value in the array, it should always start from 0, right? Because the first value is stored at a 0 displacement from the base address, right? Okay, so array name, so for an example, A0. Okay, A0 basically means value stored at 0 displacement from base address A, right? Okay, so we need to always start the indexing of array from 0, because the array name itself marks the beginning of the array definition in memory, and using the index, what we do is we create displacement. So A0 basically means value stored at displacement of 0 from base address A. A1 basically means value stored at a displacement of 1 from base address A. That is the way how the interpretation of array is done. So that is the significance of the array name. Always remember, array name marks the beginning of array definition in computer's memory, and the index is used in order to create displacement. Right, now let us move on to the next data type that you have. Is called as function. Now function is a set of instruction that is capable of performing some desired operation only when it's invoked or when it's called. Okay, so just remember, a function is a set of instruction that is capable of performing some specific operation whenever it is invoked. Right, so now what we need to do is, in order to have a function performing its operation, what you need to do is you need to declare a function first, right? Okay, so what we have is we have the declaration part and we have the definition part, right? Okay, so whenever we are declaring a function, now just see here I've specified the syntax for defining a function, but I'll be using the same syntax for elaborating the way how the function is to be declared. So whenever you're declaring a function, what you need to do is you need to specify the return type, you need to specify the function name and the parameter list, followed by semicolon here. Okay, so this set of statement followed by semicolon is the declaration statement. So return type, function name, and parameter list. So whenever you're declaring a function, you need to provide the return type, function name, parameter list, followed by semicolon. Now parameter list may, you may have a parameter list, you may not have a parameter list. Return type may be of any type, but if you do not specify the return type, as I've said, it should be by default it will return integer. Okay, by default it will return integer. So whenever you're declaring a function, you need to specify the return type, you need to specify the function name, and you need to specify the parameter list, followed by semicolon. Where function declaration will not have the function body, that is, this particular portion will not be there in case of function declaration. Now another important aspect of function declaration is that only the type of the parameter can be specified. So for example, if I'm declaring a function add that adds to integer number and returns an integer value, so it will be declared as integer add integer. So you need to specify the names of the parameters. So only the data type of the parameters can be specified. So that is the significance of declaration. So whenever you are using a function, the function has to be declared first and then it can be defined. Now this is a very simple syntax for defining a function. So here what we have is we have return type, we have the function name, we have the parameter list, and then we have the body of the function. Now whenever you are defining the function, the parameter names of the parameter always also has to be specified. Now that's the difference between declaration and definition. So whenever you're declaring, you need to place only the return type, function name, and the data type of the parameter, right? You can place the data type of the parameter. If you want to place, you can place the parameters as well, but that's not mandatory, followed by semicolon. But whenever you're defining a function, you need to specify the names of the parameters as well. So this is the general syntax for defining a function, right? So a typical C++ function definition has a function header. So this particular portion is called as the function. This particular portion is called as the function header, and this is called as the function body, right? Between the parentheses, between the pair of parentheses, whatever lies, this is called as the function body, and this is called as the function header. Now the function header has the return type, function name, the list of parameters, that the function uses in order to perform operation, whereas the function body has a set of instruction that realizes the behavior of the function, right? Okay, so here in case of function definition, there are two sections. You have function header, and you have function body, right? Okay, so function header has a return type. It specifies the type of function value the function returns. The function name marks the beginning of function definition in memory. As I've already said, in case of function name itself is the pointer to the definition of function in the computer's memory, and you have the parameter list. So it will refer to the list of parameters that the function takes in order to perform operation. And function body, it contains a set of instruction that realizes the behavior of the function. So that is the significance of function. So function has in it whenever you want to use a function, so function should be declared and function should be defined. So in case of function declaration, you need to specify the return type, function name, and the parameter list. Where the names of the parameters are optional. In case of function definition, you need to specify the return type, you need to specify the function name, you need to specify the parameter list as well as names of the parameters along with the body of the function. So that is the significance of functions, right? Okay. So now let us discuss another important data type that's called as a pointer. Now pointer is a data type in C++, right? Okay. So pointer is not a variable. Very often students confuse pointer and pointer variable. Okay, so pointer is not a variable. Pointer is a data type. Pointer variable is a variable, right? So pointer has various concepts like pointer constant, pointer value, and pointer variable associated with it, right? Now, what is pointer constant, right? Now let us consider that a variable A is allocated 2020, right? Okay, memory address. So variable A is allocated 2020 memory address, right? Okay, and address of A logically is represented with the help of ampersand A, right? So 2020 is the physical address, ampersand A is the logical address, and I can store ampersand A in some other variable, right? Let's for an example PTR, right? Okay, so we have three different representations for address of same variable, that is 2020 ampersand A and PTR. So 2020 is called as the pointer constant because the physical address can never change. That's why it's called as pointer constant. So 2020 is a pointer constant, right? Ampersand A is a pointer value, right? Okay, and PTR that holds the value of ampersand A is called as pointer variable. So you have pointer constant, you have pointer value, and pointer variable. In case of low level programming, what we do is we use pointer constant because we are allowed to work with the physical address. But in case of high level programming or mid level programming, what you cannot do is you cannot use the physical address of the variable. So that's why we take the help of pointer value and pointer variable. Right? Now let us move on to the next important aspect that is there in C++ is called as a reference. Okay. Now reference is a reference variable is an alias. Alias basically means it is a name associated with the existing variable. Right. Okay. So for an example, now here if I have a variable A, then what I can do is I can create an alias to A by some other name. So let us consider B is a reference to A. So B is alias to A. So what you can do is you can use, in order to refer to A, you can use A or you can use B. So a reference in case of C++ is a reference variable is alias variable. Okay, it's an alternative name given to an existing variable. So what we can do is, so once a reference is initialized with a variable, either the variable name or the reference name may be used to refer to the variable. So just that's what we have discussed till now. So you can refer to a particular variable using an alias, or you can refer to a particular variable using its own name. Now, a reference should not be confused with a pointer. Okay, right? There are major differences between a pointer and a reference. Okay, right? So you can have a null, you cannot have a null reference. This is very much important, right? Okay, you must always be able to assume that a reference is connected to a legitimate piece of storage, right? So you cannot have null reference. That's not allowed. So always a reference has to be associated with the memory location. Once a reference is initialized to an object, it cannot be changed to refer to any other object. Now this is one of the major distinction. Whereas pointer can be used to point to different variables at different point in time. In case of reference, if once it's initialized to a particular object, it cannot be changed to refer to another object. A reference must be initialized when it's created. Pointer can be initialized at any point in time, right? Okay. So just see, these are the major distinctions. So a pointer can be initialized with null, right? Whereas a reference cannot be initialized with a null. A pointer can point to address of, or can be made to point to different variables at different point in time, whereas reference cannot be used to point to different variables. Okay, right? Reference has to be initialized when it's created, whereas pointers can be initialized at a different point in time. So these are the major differences. So this is one important thing that you need to remember, right? The major distinction between reference and a pointer, right? Again, I'll repeat it. A pointer can be initialized with null. Reference cannot be initialized with null. A pointer can be initialized with address of different variables, whereas reference can be initialized with address of only one variable. A reference has to be initialized at the point of creation, whereas pointers can be initialized anywhere. So this is one of the important aspects that you need to remember about reference. Now let's take an example of creating a reference. So here what I have is I have a variable I that is of type integer, which is initialized with value 17. Now here what I have is I have a reference. So this is the way how what you do is you create a reference. Okay, this is the way how you create a reference. So integer asterisk R. Now I. So now R is a reference to the variable I. Okay, so this is the way how reference is created and initialized. So therefore, you can have the access to the content of the variable to either to the. So now what you can do is you can refer to variable I using the name I, or you can use name R. Okay, so this is the way how you create a reference. So therefore, you can have an access to the content of the variable either through the original variable name or through the reference. So this is the way how you create a reference. Okay, so reference is created in this particular manner, right? Okay, and it has to be initialized at the point when it's created. We'll try to elaborate it with the help of a better example. So now here, let us consider, this is the fourth program that we have to execute, the example of reference variable, okay, right? So here, again, what I've done is I've included the header file iostream.h. Now I have declared a variable and I've declared a variable d. So variable I is of type integer, where variable d is of type double, right? Okay. Then I've created a reference to I. So R is a reference to I and S is a reference to d. Okay. Right, now just see here what I've done. I've declared two variables I and d of type integer and double, and I've declared two references. R is referring to I and S is referring to double, right? Then I've initialized I with 5, right? And then I've displayed the value of I. So here I'm displaying the value of I using the variable I itself, so it will print 5, and here I'm using reference R, so it will refer to the value of I, so it will again print 5. Now here D I have initialized to 11.7. Okay, then I'm printing the value of D using D itself, it will print 11.7, and I'm using reference to D, that is S, again it will print 11.7 because R and S are reference to I and D. Right, so this is the way how the reference variables are to be used. So reference variables, again I'll repeat it, it's alias or an alternative name given to the existing variable, but it differs from the pointer in different manner. So first difference is that pointer can be initialized with null, reference cannot be initialized with null. Second difference is that pointer can be made to hold address of different variables, whereas reference can be made to hold address of only, or reference of only one variable. Okay, and then a reference has to be initialized at the point of creation, where pointers can be initialized very late in the program. Now let us move on to the next data type that's called a structure. Now structure is a mechanism for bundling data of different type. Okay, right? So in contrary to array, now one of the major limitations of array is that array is capable of assembling values of the same type, right? Okay? So in order to overcome that, they designed a new data type that is called a structure that is capable of assembling data of different type. Okay, So structure is a mechanism for bundling data of different type in contrast to the array. So whenever you are declaring a structure, so you need to declare the structure in this particular manner. So the general syntax for structure is that you have structure, keyword struct, then you have structure name, and you have members listed in the structure, right? Okay. Now, structures can have member functions. You can so there are different types of members that a structure can have. But remember that whenever you want to create a structure, first what you need to do is you need to define the composition of the structure, right? Okay. So structure name, member one, member two to member n. Now, as I've said, the members of the structure will always be public. Okay, right? In contrast to class, where in case of class, the members of the class will be private in nature, right? Now again, now what we have is we have another data type that's called as class. Now class is a user defined data type that's capable of holding data of different type, right? Where we have class members, and we have attributes, or we have data members, we have member functions. Okay, right? And in contrast to structure, the members of the class are private. As we have learned in the previous class, that class is a mechanism for bundling the data and function into a single unit, that which is called as encapsulation. So that is the way how class is being built up, right? Okay. So whenever you are trying to create a class, so first what you need to do is you need to define the composition of the class. So you have class name, and you have the members. Okay. So you can have data members, it can have member functions, right? Now next one is typedef. Typedef is a mechanism for creating a new data type out of the existing data type, right? Okay, so it's a mechanism for creating a new data type, or you can create a new name for an existing data type, right? Okay, so here the syntax for typedef is that so you have typedef, type, and a new name for the data type. For an example, typedef integer feet. So you're defining a data type feet that is capable of resembling the characteristics of integer. Okay, right? So that is the way how the interpretation is done, and later on feet can be used in order to declare variable that will have resemblance to that of integer data type. So this is the way how the typedef works. So you have typedef, type, and the name. So typedef integer and feet. So if we are defining a data type feet which will have the characteristics of integer, so later on feet can be used in order to declare variable of type integer, type feet that has a resemblance with integer. So in today's class, what we have learned about is we have learned about the various data types that C++ have. We learned about that there are three categories of data type: primary, derived, and user-defined data type. In case of primary data type, you have integer, character, floating point, and void. In case of derived data type, you have function, arrays, pointers, and reference. In case of user-defined data type, you have classes, structure, union, enumeration, and typedef. Okay, and we have learned about the byte requirement of the individual data types as well as the range. We've learned about what is an array. We have learned about the definition of the array, right? We've learned about the significance of the array name. We've learned about the significance of starting the index from 0. We have learned about functions. We have learned about function declaration. We have learned about function definition. We have learned about composition of function declaration and composition of function definition and their significances. And we have learned about pointer. We have learned about pointer constant. We have learned about pointer variable. We have learned about pointer value. We have learned about reference. We have learned about the basic distinction between pointers and reference. We have learned about how to create a reference. We have written program for implementing the reference variable, right? Again, and we have learned what is a structure, right? We have learned that the members of the structure will be public in nature. We have learned about class. We have learned that the members of the class will be private in nature. We have learned about the reason for bonding the data into structures and classes. So in the next class, what we will learn about is we have also learned about typedef and way how typedef can be used for creating new data type based on the existing type. So in the next class, we will be discussing the rest of the data types. Thank you very much and have a very good day.